Chapter 7.4. In the next several sections of Chapter 7, we are going to look at factoring polynomials, which is a major concept in algebra, Algebra 2, and Math Beyond. Today we're going to take a specific look at what factored form of a polynomial is and what its importance is. So before we jump in, let's take a look at a whole number like the number 12. If I ask you to find its factors, you are going to break down that number 12 into smaller numbers that would multiply together in order to get 12, such as 2 and 6, or 3 and 4, or the prime factorization of 2 times 2 times 3. That also produces 12. So when we factor a polynomial, what we're doing is we're taking a higher degree polynomial and breaking it down into smaller degree polynomials that would multiply together to get that larger degree polynomial. When we talk about the solutions or the roots of a polynomial, we are finding the value of x that makes that polynomial equal to 0. You can see this on the graph of a polynomial at its x-intercepts, or where it crosses the x-axis. Factors are simply numbers that multiply together to equal the original value. So when we factor a polynomial, we break it down into smaller degree polynomials that, when multiplied together, would give us the same result as that beginning one. So let's take a look at 2x squared minus 8x. This is standard form, and you can see that the degree of this polynomial is 2. If I were to factor out the GCF, I would divide a 2x out of both of these terms, and my result would be 2x times x minus 4. And this is considered the factored form. I broke this polynomial, 2x squared minus 8x, down into smaller linear factors that, when multiplied back together, would give me that starting polynomial. Now, our key concept today is to find solutions, also our x-intercepts are called the roots of the polynomial, by factoring the polynomial, setting each factor equal to 0, and then solving for x. Before we jump into doing that, let's just remind ourselves how to factor using the greatest common factor. So as I look across this first polynomial in example 1a, I see that I could divide a 4x cubed out of both of these terms. When I divide out a 4x cubed, I would be left with just x plus 6. So here are two smaller factors that, when put back together, would result in that original polynomial. In our next one, as I look across the three terms of this trinomial, it looks like I can divide out a 5x from all three of these terms. When I do that, I'm left with 5x squared minus 2x plus 1. And again, these are two lesser degree polynomials that, when multiplied together, would give me back my original. So what I'm doing is factoring by using the greatest common factor. All right, in example 2 now, we are given a polynomial that's already in factored form, x minus 4 times x plus 6. I want to find its solutions. Well, if you remember, our key concept from above said to take each one of our factors, set it equal to 0, and solve for x. Well, I would add 4 over to the other side to get x by itself, and so one solution is x equals 4. My other solution would be taking my other factor, setting it equal to 0, and solving, and that would give me x equals negative 6. I almost forgot that negative in there. Let's make that a little bit clearer. That's x equals negative 6. All right, in example 3, I need to factor my polynomial first using the GCF and then find its solutions. So if I take a look at 2x squared minus 18x, I see that I can divide a 2x out of both of those terms, and I would be left with x minus 9. Remember, a good way to check this is to redistribute 2x back into the parentheses and see if you come up with your original polynomial. Well, now I have it down to my two factors. I'm going to set each factor equal to 0 and solve for x. When I solve this first one, I get x equals 0 over 2, which is just x equals 0. And now my other factor, x minus 9, add the 9 over, and I have x equals 9. Now, interestingly enough, when we take a look at the graph of that function, and turn that on here, you can see here's our big parabola that goes down and up, and you can see that it crosses here at the x-axis at 0 and at 9. And we said those were our two solutions for this polynomial. All right, in example 4, we're going to factor this polynomial. Oh, sorry, the polynomial is already given to us in factors, and we want to find its solutions. So take each factor, set it equal to 0, and solve. We're going to subtract 1 over. That gives me 2x equals -1. Now I divide over the 2, and I get x equals -1/2. Next up, I got x minus 5 equals 0. Add the 5 over, and x equals +5. The two solutions of this factored polynomial are -1/2 and 5. All right, in example 5 here, we're going to go back to graphing our polynomial. We can use our graphing calculator, or we can use Desmos. And for this example, I've graphed it on Desmos for you. And we're going to discuss what these factors in our x-intercepts have in common. So here we're going to take a look at the graph of x minus 4 times x plus 2. I have it graphed here on Desmos for us, and you can see it's this green parabola that dips down and comes back up. It looks here as it crosses the x-intercept at 4 and -2. And these are our two solutions. So back over here, it says to use these factors to find the x-intercepts. We're going to plot those x-intercepts here at -2 and 4. And I would get those by setting each factor equal to 0 and solving for x. And there's my two x-intercepts, my two solutions. And here where it says to describe the relationship between the solutions and the x-intercepts, I'm going to say that the solutions equal my x-intercepts and can be found from my factors. All right. We're going to finish graphing this parabola here. I saw that on the previous page. It looked like it had a vertex down here at 1 over -9, and it went through, the y-intercept down there at -8. Oops, it wanted to graph a straight line for me. That's okay. That's a pretty good parabola for us today. All right, final example here. It says to factor the polynomial 3x squared minus 12x by finding the GCF, then find the solutions, or the x-intercepts, and give a sassy sketch what this graph will look like. All right, I have 3x squared minus 12x. If I factor out a GCF, it looks like I can divide a 3x out of both of those terms, and I'll be left with x minus 4. And now that means my two zeros are, if I divide over my 3, that gives me x equals 0. And my other one here, x minus 4, looks like my other 0 is going to be +4. So these, remember, are my x-intercepts. And if I want to do a sassy sketch here of what this parabola might look like, it looks like it's going to pass through the x-axis at 0 and at 4. This is going to be a parabola that opens up, so it's, we're just going to say it's, whoa. It looks something, not so straight. That looks something, oh boy, my marker's really going off track here. Let's try this one last time and see if we can get it. There we go. That's what that might look like. All right, hopefully you had better luck with your pencil on your notes. We'll see you tomorrow in class.